7.5 is about exponential and logarithmic equations. Example 1 talks about what's the solution of 16 to the 3x equals 8. Now, we've kind of did this before a couple sections ago, but let's take a look at it again, kind of refresh our memory. What does 16 break down into? And again, we could do this the long way. 8 and 2, which is 4 and 2, which is 2 and 2. So prime is 1, 2, 3, 4. So 2 to the 4th. 16 breaks down to 2 to the 4th to the 3x equals, and 8 breaks down again into 4 and 2, which is 2 and 2, which is 2 cubed. Okay, so let's go ahead from here. Power 2 power, we multiply. So 2 to the 12x equals 2 cubed. Same base, we're good. It's 12x equals 3 divided by 12. X equals 1/4. Now that's all well and good if you have the same base. That all broke down, if you take a look back, it all broke down into 2's. So we had like bases, it was fine. If you look at 15 and 285, 15 does not factor into something that you can break down nicely. 15 is just 3 times 5, so there's nothing multiple. There's nothing I can do. So we're going to go back into last section where we start to expand this stuff a little bit. And how do I take this 3x and bring it down? Well, in order to do that, I need to take the log. So I could take the log of 15 to 3x, but if I do something to the left side of the equal sign, I always have to do it to the right side of the equal sign. So get the log of 285 over here as well. Now, we use that expansion principle where power to a power, we can bring that down in front. So you get 3x, the log of 15, equals the log of 285. Remember, everything that's happening here on the left side is multiplication. It's 3 times x, which is times the log of 15. How do I get the x by itself? Well, I could just go ahead and divide by everything that's attached to the x. 3 log of 15 and divide by 3 log of 15. The logs are going to cancel. The 3's are going to cancel. I'm left with just x on the left side. And then just punch in your calculator, log 285 divided by 3 log of 15. And it gives me to be about 0.696, somewhere in that area. Example 4 is a story problem. It says, what is sustainable, renewable natural resource when you manage forests properly? Your lumber company has 1.2 million trees. You plan to harvest 7% of the trees each year. How many years will it take to harvest half of the trees? Right there. So again, let's define our variables. We're looking at, this looks like exponential decay basically because we're talking about 7%. When you see percentages, that's more of our exponential thing. So if we're looking at y equals a, exponential decay, remember, is 1 plus r to the t, right? And because we're doing it each year. So let's define our variables. Our a in this case is 1,200,000. That's our initial amount. What's our R? Well, it's 7%, and you're taking them out. You're harvesting them. So it's a negative 7%, or a negative 0.07 is your R. Okay, so when I punch this into my equation, and we want that to equal what? Well, what's half of 1.2? Our final number, or TN, or total number of trees, we want to get it to is 600,000, because that's half of 1.2 million, or 1,200,000. So let's start setting this up. We've got 600,000 equals 1,200,000 times 1 plus negative 0.7, or it's maybe 1 minus 0.07 to the t. We don't know how long it's going to take. This is where this comes in. You're trying to solve this equation. So we get 600,000 equals 1,200,000 times 0.93 to the t. So let's start by isolating my variable. I can get rid of this 1.2 million by dividing it on both sides. So we end up with 0.93 to the t equals 0.5. Why? Because 600,000 divided by that is 1/2, or 0.5. You can leave it that way. So then what do? Well, again, it comes down to we need to get that t down. So in order to do that, I've got to take the log of both sides. Log of 0.5 equals the log of 0.93 to the t. Again, I could take that exponent now and put it down in front. So that gives me the log of 0.5 equals t, the log of 0.93. How do I solve for t? Divide by the log of 0.93. That cancels, I end up with t, and what I end up doing is t is approximately, or time is approximately 9.55 years. Example 5 now, you start with a log, so you can't take the log of both sides. You're not going to take a log of a log, okay? So the greatest thing in the world is, and how you can remember this, is if you have a log, you got to go to exponential. If you're in an exponent, you got to go to a log. And that's the best way to go about attacking this. So remember, the log with no base, that base is really 10. Cross the river, so 10 squared equals 4x minus 3. When I put it back into exponential form, I end up being able to solve this. 10 squared is 100, equals 4x minus 3. Add 3, you get 4x equals 103. Divide by 4, get x is equal to 25.75. Example 6 is solved. Now we have multiple logs. You've got to get it to one log. Just like everything else, we only deal with one log at a time. So what does this mean? Addition, based on what we did just yesterday, addition and multiplication are tied together. So really what this ends up doing, so I can condense this, is I'm going to end up with the log, you read it once, of x minus 3 times x equals 1. Okay, well, what do I do with the x? Okay, well, I'm going to have to, let's get rid of the log first, and let's make this simpler. So again, remember, base 10, cross the river, 1. So x times x minus 3 equals 10 to the first power. Okay, how do I solve? Well, again, distribute the x through. You get x squared minus 3x equals 10. It's a quadratic, so I got to bring the 10 over. X squared minus 3x, subtract 10 from both sides. Minus 10 equals 0. Now, again, we have a quadratic here. Me, personally, I punched in my calculator. We've talked about that in various ways to solve. You can use quadratic formula. There's a lot of things that you can do, but you end up with your answers to be 5 and then -2 are both my answers. Make sure that you take each one of these answers and plug them back into the original equation. So I'm going to take the 5 and plug it back in for x here and x here. Make sure it gives me 1. Take the -2, plug it back in. You'll find out that -2 doesn't work. And my only answer here is 5.